In this demonstration, I'm going to show you the effects that liquid nitrogen has on various objects. Now, liquid nitrogen, that's a liquid gas at about a temperature of approximately 200 degrees below 0 Celsius. And when things are dropped into liquid nitrogen, they get extremely cold, extremely fast, and become very rigid. Now, to demonstrate this, I'm going to take this little triangle, which is made of like solder, and when you hit it with a little piece of metal, I'll do this near my microphone, it goes clunk, clunk, clunk. Pretty boring stuff. But if we take another triangle that's been soaking in liquid nitrogen for about 5 minutes or so, then when I hit it, let's see what kind of sound it makes. Ah, much prettier. Call those cows into dinner. Here we go. Now, these objects are very soft or plastic at room temperature. Now, plastic means that when you change their shape, they stay changed, as opposed to elastic, when you change the shape and it returns to its original shape. Now, to show you the difference here, we have this little piece of this spring, which is made of another solder. And let's get this little weight hooked on here and show you what happens. Now, when this stretches out of shape, it won't return to its original shape. Watch. Yeah, it's ruined. It's all stretched out of shape, and it will never go back again. But if we take another spring that's been soaking in liquid nitrogen, voila, and we hook our little mass on the end of this, then it will stretch out of shape, but it can be returned to its original shape until it starts getting warm, and then it starts losing its springiness. See? Okay. See, it was a little more springy, but it started to get warm, so it stretched out of shape again. Okay, now let's try something a little different. Let's get a balloon. Here we go. I just happen to have a balloon right here. And there's air inside the balloon. And so if I pour liquid nitrogen all over the balloon, the air inside the balloon will compress. It will become more dense. And the otherwise flexible rubber surface will become rigid. So we'll see what's going to happen here to the balloon. Ah! Ah! Neat stuff, Maynard. It's a prune balloon. Okay? And as it warms up again, it will start to expand back to its original size. Now, what if we supercool something that has a rigid surface, like, say, a ping pong ball, which I happen to have right here. Okay? And get our balloon out of the way. And there's the ping pong ball. It has a rigid surface. But if I supercool this, the air inside the balloon, ping pong ball, will become more dense. And it will try to pull in on the inside surface of the ball. All right? Now, that's cooled enough here. I can pull this out and show you what happens. Now, it's not breaking because this is a sphere, and spheres are really good shapes for holding pressure. But it doesn't take a whole lot of extra pressure to get this balloon to shatter into a zillion pieces. Okay? Now, another flexible object I'm going to use here is a piece of tubing. This is a piece of flexible tubing, not unlike the ones that are in your lab. And we're going to drop the tubing. And, ooh, there we go. Spew, spew, like a... Ooh, this is a mess. I'm going to get another glove out. Now, that's really flexible tubing, but when we drop it in the liquid nitrogen, it becomes super rigid. So when I hit it, we can expect it to shatter quite a bit, too. So here we go. I got to aim real carefully with this. Ah, my finger! Just kidding. This is a silly putty inside a rubber glove, but this could have been a real finger. So we don't want to do this with real fingers. Let's try this with the tubing again and show you what really should have happened there. Okay? All over the place. Tubing, fingers, anything becomes instant glass. It's really a mess. And now, in conclusion, we're going to take some cool water, which, compared to the liquid nitrogen, is really, really hot. So when I drop the liquid nitrogen in there, it will begin to boil. And we get a special effect, not unlike something out of a horror movie. Ooh-ah. And that's it. Really cool.